Yo, yo, yo! What's up, everybody? Welcome back. Today we're working on our window manager. Look at this bad boy. Today's topic, though, is doing hot reloading of the renderer code. As of last stream, we started doing like a little bit of window management, right? Wow, we can like render a really hot yellow title bar, and we can like drag these guys around. Easy peasy, wonderful. But I was thinking, like, the next thing that I want to do is I want to start, like, iterating on design of this thing, right? We kind of just put, like, big yellow borders here as a placeholder. But as we start, if we start looking at, like, oh, how do I want the title bar to look? Do I want the corners rounded? How do I draw, like, the X and all that stuff? I think it would be nice if we could kind of, like, leave our window state intact, but reinitialize all of our renderer state so that we can kind of just press a button and see like the changes that we made show up immediately. That's what I want to try. And so that means that we need to have some form of hot reloading, right? So what I'm thinking is somewhere we're gonna have some Linux shared object, right? Renderer, render.so. And this guy is going to do all of the rendering, right? So right now, the way it works is we have some sort of system design is like we have state, general like window state. This is kind of managed or like updated by several things, right? Some being like input happened, right? So I move the mouse, the cursor state changes, it moves, according to wherever the last input event was. We have like apps, right? So each time that this little demo app updates his frame, he will like send a new frame over, and that will get injected into our compositor state, right? Then we have this renderer, and this renderer like looks at the state and iterates over all of the windows that he wants to render and renders them, right? And this action is triggered by some backend. So this, in our case, is like a Wayland backend where there's this window that's being shown, and every once in a while, this window will tell us, like Kwin, the window manager we're connected to put our window manager inside. He will say, "Hey, it's time to update," and we'll go, "Oh, okay, that means that we have to do this render stuff." And so what I want to do is have this kind of like event call into like render.so. I'm not really sure how yet. But this guy needs to like somehow render all the windows. Now, this could be done by this guy exporting a function, render window, and render cursor, right? That probably makes his API surface area pretty low. But another option is that we just call render, and he needs to pass in like the whole compositor state, which would mean that these guys have to be kept in sync. But I'm not really sure. Because I don't really know what this can export, right? So we need this to have like some shared object. And this guy, typically when we have shared objects, I think they export like C APIs. I don't know if that is true in Zigland, if we have to do that, or if we're allowed to pass like Zig code over a dynamic object boundary like that. So I think what we have to do is we have to try making a shared object in Zig, just kind of see what we're allowed to do, then figure out how to like dynamically open it and close it and all that stuff. Then like make a renderer shared object that we can work with. And then figure out the rest from there. So step one. How the fuck do you make a shared object in Zig? Zig shared object. We found something earlier. I typed build Zig maybe. Zig build system. Maybe we search dynamic. Right. So we should be able to call in our build system. We should be able to call b add library, make some library, and give him a little linkage dynamic on him. So if we go into our thing and we go build Zig here, maybe we should make a new like dynamic library test. and we export some function, hello, I guess. And we'll try, like, right now being like an errorable function, and we'll just kind of see what happens. You know? Import stood. Okay, and then if we go to main now, or build.zig, and we try to make this thing, like, what the fuck happens? What the fuck happens? Make DL. Or I guess like a DL tests. Dynamic library tests. And we're gonna be like, B add library, I guess. Linkage dynamic. Export or extern? Probably. Good point. Root module. We have to make a new module here. Root source file is, what is it? Source DL test. And target, probably. All right. And then can we just fucking, like, install that shit? Sure. Okay. So let's take a look at what's in here. Oh, probably zig out lib. Nice. Anything in this thing? We're looking for some sort of like hello on here, right? Not exported. Okay. Export? Zig build and this. Okay, so this is a good clue, right? So it looks like if we are exporting a function, we need to conform to sysv calling convention. So, you know, we probably should be able to do this. No error return type. Yep, okay. And then if we try to DL open this thing, can we do something like, stood POSIX DL open? Is that where this lives? OS Linux DL open? How is DL open like a libc thing? Is this something we could do in Zig? Zig DL open. Do we need to link against libc to do DL open or what? Support dynamic libraries and standard library. These things do seem to exist. Stood dynamic. I mean, this was like maybe an old thing, 2019, so this might not be up to date. Dynlib sounds like maybe where we want to go. Stood dynlib and what do we have, like open? Surely, right? Then can we like get function pointers from this thing? Like this has to get like mapped into our process memory space. And you somehow, oh, there's lookup in the Windows version. Does Windows dynlib, is this like a type def here? Yeah, so we have dynlib here that these guys are going to implement some sort of same API. So we're going to have open and lookup. Lookup returns a thing with a type that we provide. And he does an automatic cast of that thing. Yeah, that seems pretty good. Looks pretty good. So we should be able to be like stood dynlib open of zig out lib dl, what was it called? Zig out lib dl test. Okay. DL is this, right? Probably this thing is available. And then we know the function signature of this thing, right? So we're going to be like, look up this function pointer. Ooh, extern. Do we specify call conv C or something? Right? I don't really know how this is supposed to be done. Right? It kind of feels like this is what we would be doing. Something like this. I guess kind of like this. A function that takes no parameters with C calling convention and returns void. And then can I call H like this? And in here, if we go to our build zig and we also, quickly make a binary out of this thing, dltest.exe is add executable, and we're kind of building this based off the same module. And we install this thing. Okay, what's this about? Expected type, this, found that, so this thing has to be var, okay. Cannot call this thing, so we kind of dereference that. Okay. And he is not happy. Not happy. So this is probably that he didn't find it. Oh, okay, so he did find it, but then he's getting angry. So maybe like this extern function? No. I would love an example of this. Do you think they have tests? They have open, but they don't have lookup. Const function, maybe? You have to make this call conv C? Yeah, that's true. But I thought it automatically did that. But you're right, that is a little concerning. Can we... extern? But you can't put extern here, I don't think. He doesn't like that. So we're missing something. Zig DL sim lookup. No, that's correct. I omitted that name. Does this thing have an example in here? Did I miss this? Also, I kind of just made up what I'm supposed to be doing here. Are you installing the .so? Yep. Yep. Zig DL sim lookup example. Maybe this will help us. Oh, is it dynlib? My bad, not DLSim. We could look at what the fucking idiot says. Okay, what about like exporting? Okay, so I mean, this guy did like this fucking idiot who, he's an idiot for sure. He does just have like function pointers like this. I think that the call conv C is kind of implicit. So I guess what we want to do is we want to figure out why he's crashing. That feels like the play. Do you think that we need to like map something in here? It's just open, close, lookup, right? Open, close, lookup. So, okay, if I write like hello2 here, I'm assuming that the failure mode is different. Right? So here's like attempt to use a null value. Right? So it looks like we're resolving the symbol, but when we call it, he's like freaking the fuck out. Specifically because he's like accessing memory that isn't supposed to be accessed. I would be curious to know, before we get too crazy here, can we try to like separate the problems, right? So we could be in a scenario where the loading is broken, or a scenario where the export is broken, right? Just list the symbols exported. I did take a look at that already. Like we already confirmed that they were open. Greyhouder's got a link for me. What the fuck? Oh, I don't know what this means. That's crazy. I'm gonna. We'll come back to that maybe. But what I want to do is I want to try in Sealand opening this instead, because we can prove to ourselves that like where the bug is. You know what I mean? Do you try const function? No, but like should that matter? And maybe maybe it's also not a pointer. Could be this, right? Could be that he doesn't want pointer there. Nope. Okay, we'll try const, but I don't believe that should matter. But I'm willing to try. Yeah, same thing. Same thing. Okay. So let's try the C version of this thing. Right? Fuck Zig completely for now. And let's just make sure that we understand how this is usually supposed to work. Because I think it's a good starting point. Okay. Test DL open C. So here we export a function. I forget how you do like C export dynamic GCC dynamic library. Okay. Boom, 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 boom. There's like GCC. This sounds familiar. Okay. So test.so shared test.c or something. Do we have hello in here? Beautiful. However, I'm not positive that was right, but we'll see. Because I assume that I can't go like test.so, right? He's like, that's not how this works. Then if I want like test DL open, let's start by trying to just call hello. So here we'll have like a void hello function. No DL open yet. So this comes from test DL open, and we link. It's like -l test.so or something. How do you do this? Cannot find this. Is it no colon? It's right here. Okay, so we might have fucked up the GCC export. GCC build dynamic library. I just want like some like fucking. Oh, fpic does sound familiar. GCC dash shared. Yeah, wait. That does sound okay. GCC dash shared dash o test dot lib test dot so probably forgot test dot c. File lib test dot so. This is shared object. Yeah, okay, that should be right. And then can we look to make sure libtest.so, he does have hello in here. Wonderful. So then if I do GCC test from test DL open, let's see, he's going to be like, I can't fucking find hello. And then I'm like, L libtest.so. What if I do big L dot dash L test? There we go. Okay. So now this guy's like, I link against libtest. I can't find him. So if I do LD library path is here and I run test, that guy prints hello. Okay. So we now have a C library that we know works, right? Now if we go into test here and we try to do DL, how is this? Man, DL open. This comes from DL FCN. So in the C world, we should be able to be like, we DL open this thing, which returns what? A void star. And then we probably like DL sim as well. Okay. So here we are like, open up lib test so. This is all in CLAN again with some flags. I don't really know it right now. We have a handle here, and then we look in this thing for hello. Okay. So this is like a oh, I can't remember how to see function pointers. Void hello DL. It's like this, right? And then we call hello DL like this. I think it's like something like that. Okay. So this is kind of the same thing. Hello DL. Okay, so he didn't find it, which is interesting. So maybe we're using this wrong. Can we just ask the idiot? Can you give me a quick DL open DL sim example to call a hello void hello void function on a shared object? Let's just see. DL open. Maybe we need this guy. Then he gets a handle. He calls DL sim on the handle with hello. Okay. Okay, there we go. So now if we call hello DL. Okay. Okay, so we have a C to C version that's working correctly, right? A C export and a C import. Now the question is if I replace this to use the thing that we exported from Zig, does it still work? Right? What is it? It's like lib test DLSO. So if this works, then it's the loading problem. And if it doesn't work, then it is the export that is broken. Okay, so good news. This seg faults. So we can kind of bisect the problem again, where if we go into test test DL test here .zig. So if we open the C library that we know works, this guy who has a hello function, if we zig build, zig out bin, you know, whatever the fuck it was called, DL test, he is also seg faulting. So that's interesting. So we've kind of like fucked this up in like many ways. Let's try calling a callcom C in here. Segmentation fault at address 0. Interesting. Interesting. Let's just triple check that this guy was libtest.so. Okay, so this worked. It could be also that this guy needs to link against libc if we're trying to call printf in here, right? It could be that he loaded this function correctly, but this function depends on libc and he didn't figure that out yet. I would like to see if that changes anything. So, DL test exe link libc. Let's just try. It seems like the type of shit that would happen. I've seen that like segfault happen before. Ah, perfect. Okay, cool. So we have an example now of Zig loading a shared library and printing and like calling print, right? So that's good. Now we need to fix the export side. So let's throw callconf C on here as well. It feels like the type of thing that we might need. And can we go back to maybe Zig build? And can we go back to our test on C side? And he's trying to open now Zig out lib test. Still segfaulting. So maybe I need to link libc on the execute of the shared object as well, which Grey Hatter just also suggested, but it's, yeah, I agree. So what is this DL, what is it, test? Still no bueno. Can we do maybe GCC this guy, and can we turn on like GDB here and run tests on this thing? Okay, so this is interesting, right? We see some example, we see proof that this executable is loading the DL test function and then falling over inside. So it looks like he's in debug print, right? So he knows that he's trying to print something. exe needs lc2. That's a good point, right? I kind of assumed that this would automatically do that, but we could, no. Because GCC should automatically link libc to this guy. DL test link libc is supposed to be done here. Okay, let's also do a quick use LLVM here, just in case. Maybe Zig's like custom debug implementation gets a little fucky wucky. I don't really believe that that's the case, but it is a possibility. Oh. Okay. Okay, so that's interesting. So does this whole stack work now? Yes. Okay, so null deref is saying, just a hunch, looks like the Zig standard lib is not initializing in the shared lib. I agree with that. So there's two options here. It feels kind of like the Zig debug, the Zig like custom debug impl is not like correctly, maybe correctly is a strong word. It feels like it's not running some sort of like global in it, right? And if I say, please use LLVM instead, he seems a lot happier. So I don't know if that's a misuse on my part, but it feels like it's doing something different, at the very least. I think we can confidently say that something different is happening. Yeah, so my guess would be like init hooks when using LLVM are being set up and like on library load do all this stuff. And when we're not using LLVM, that's not the case. I'd be curious to see, do we need to link libc if we build with LLVM on the library? We might not have to, right? Yeah. So this guy does not technically need libc, he just needs a little bit of love. Okay. So it feels like we're okay here. And let's just double check, do we need libc on this side? Yes. So why do we need libc? Hold on. Oh, this is calling the wrong function. My bad. This should be looking at zig out bin or lib. Okay, this is zig to zig now. Let's just double check that works as well. Okay, so it does seem like he needs libc. Maybe let's try that. Yeah. Okay, I don't know why he needs libc. It feels like he shouldn't. But it looks like As far as I can tell from just kind of throwing things at the wall, not trying, or not reading, it looks like we need Zig exe loading dynamic library needs libc, and the shared object needs LLVM. That's what it looks like to me. That's what it looks like. Are you sure it doesn't work by default with stood dynamic library dl dynlib? Is dl dynlib different? So we have, if we're not using link libc, we have elf dynlib, else dl dynlib. So you're saying maybe I huck dl dynlib directly, kind of force that path? Because this is calling stood c dlsim. But like, I would think that this should work either way. You know what I mean? I would think. Because this elf dynlib shouldn't need libc. There's something weird happening here. I would like to also try one last thing where we do dl test exe u LLVM, but no link libc. Okay, so that also seg faults. I'd be kind of curious as to why. We can kind of easily see where this is coming from. No, we can't. It's broken. Okay. I don't have a good answer for this, right? Because it seems like, to me, it feels like something's broken. That's how it seems to me. Right? But I could be missing something. Maybe we're supposed to manually call some initialization. You don't need to link libc, but dynamic loading with the C API I'm sure does some weird stuff. But like, okay, so my mental model of how this works is like .so provides, there's like some code blob in here, right? Some code is in here. And this gets like, when we DL open this thing gets like mapped into my process memory, right? So like this address gets set at like 0x1234. And then my understanding is that in here as well, there's like some function that's like in it, some like special functions. And so what my understanding is that when Zig is loading this shared object without libc, he's mapping this into his memory somehow, and then we correctly find where this function lives in this thing, and when we call it, he seg faults for some fucking reason that I don't know yet, right? Then when we do have libc, he does not do memory mapping himself, but he calls out to like libdl, who is like part of the C standard library or whatever, and this guy does loading the C library way. And I would expect that those should end in the same result. Right? But they're not for some reason. Right? So my guess here would be either that Zig's standard library is technically correct, but I am missing something, or Zig's standard library is doing something incorrect and I should just use libc. And I don't know which one of those it is, right? What does LDD say about the library that you're looking at, or libdl? Okay, I'm not sure if you're asking about libdl, like actual LDL or like my dynamic library. Libdl is a bunch of magic. I bet libdl needs C. Yeah, that would make sense to me. I guess I think that we're kind of talking past each other a little bit, where I'm saying I don't know why I would need libc at all, right? Like I don't know why I would need libdl at all. Why the fuck is like Zig's standard library just not like doing it, whatever it's supposed to be doing, Lookup depends on stood C. Oh, is that true? No, I think. Ooh, elf dynlib. I think lookup address should work. It depends on like which path we're in the Zig standard library. I think that there's kind of like the elf. There's elf dynlib, which is like Zig's internal impl, and then there's dyn, the other one, DL dynlib, which is using libdl. So I don't think that the lookup when we're using not libc depends on dlsim. I don't think. Right? It seems like he's doing like the elf parsing himself. But okay. For now, I think I will come back to this. I might like do some Googling, post some questions in Zig Discord or something, because it could just be that like this is like known broken. It could be that I'm using it wrong. Both of those are likely to me. But for now, let's just do the thing that works, which is our executable will link libc, and our dynamic library that we're making will use LVM. That's the two constraints that we'll add for now. So let's try to figure out what a good API for our renderer would be. Right? So how do we export what our renderer currently does through a C API? So what does, ideally we get as far as we can, right? So right now we iterate over renderables in our renderer, which are just kind of like windows in this world. Oops, yeah, I meant to say that DL download lookup depends on CDL. Some, yeah, makes sense. Makes sense. Okay, so it would be nice if we could get the iteration logic into here as well. So okay, so we have like some GL stuff, right? GL clear depth, GL clear color, all this stuff. We do some like time calculation. The tricky part here is our compositor state needs to make it over the API boundary, right? So if our structures have the same format, we might be able to like make this renderable thing. Let me look for a second. Hold on. Our renderable structure, it's not like impossible that if we just put like a function, if we just pass a like a void star over the C boundary to like a complex Zig type, like he might be okay with that. So can we go into our like little test function again? And if we say, you know, my Zig type, and in here maybe we have like an array list or something, like, right? Items. Brain farting? Let's do something like this, right? Can we, if take this thing in, actually, can we just do this? Items stood array list i32. Like, is this the thing that we're allowed to do? Then can we do like items append one, you know, like this. Stood heap general purpose allocator. Alloc is GPA allocator. I'm not going to bother doing leak checks or anything right now. I just want to know if this is okay. So this is now going to be like stood array list i32, like this. And I want to know if I can call this with this guy and iterate over these things. So for items, sure. Can we print this guy? I don't see why this wouldn't work. But we should check. Okay. Okay, so that's good. Um, we do see 1, 2, 3, 4 printed here, which makes it seem like we kind of have the ability to put past complex types. So all we have to do is make sure that like if we ever change types that we actually restart. Um, we could also do some like sanity checks on anything that's going to go over the API boundary, like make sure that the first field in this thing is a magic value that will change every time we update the structure or something, or like maybe like the first field is the size of itself or something like that. But it seems like it's reasonable for us to kind of just pass whatever we want over the boundary, whatever we want. Which makes me think, what we have to worry about now is state. So there are some things that are like there are some things that we're compiling OpenGL programs on the fly and storing their their representation ourselves. That probably all should live in the shared object. So I think what I want to do is just pass over our compositor state. Like if we look at what this renderer has, he has time, render in progress, GL state. And I think in reality, all of the rendering is like based off of these two fields. This stuff is like OpenGL context and like compiled programs, buffers, stuff like that. All of this can live in the shared object, which means that the only thing that we really have to pass in is this compositor state, I think. So I think step 1 here is to make an API that, like a C API that we can call that just works on this. Yeah, that's kind of my thought. So let's start with doing something like this. Oh, DL, like renderer state or something. He is gonna hold the OpenGL state. I guess that's kind of it, which means that he doesn't need to be a new structure. We just kind of want like init GL state, which will return GL render state. Where are allocations gonna live for this thing, right? I guess he could just take in pointers to stud allocators and stuff. There's nothing really problematic about that. We can guarantee that like we compile this shared object at the same Zig version at the same time, right? Like I think we're okay to guarantee that stuff. Which means that we can kind of just do whatever we want here, right? We can do like stud mem allocator, right? Whatever this like GL context currently takes, I guess we can do it. We can maybe do something where we have like init GL state params is probably the cleanest way to do this across an API boundary. Right? Where we kind of take all the stuff that was in here, and this now goes in here, right? Boom, 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 boom. And this is going to say like init GL state params. Something like this. You know? Would be init pin be easier than requiring allocator? Some things do require allocators, but yeah, in some cases I think you could be right here. But I think in this particular case, this thing is already allocating stuff inside, so I'm just not going to worry about it. Yeah. I think it's okay. I think for these like high level these like big top level types, I'm not really as worried about like keeping things on stack and stuff. You know? Okay. So this guy's like params, I guess. Create one of me. He's going to eventually return that thing. I guess this thing should allow failure. So if we fail, we return null. We will kind of say that this allocator is leaky. That's kind of an expectation that we can have. And whoever calls this thing will like put all allocations on this thing on like his, yeah, we will track these ourselves, I think. I think that's fine. Okay, so now we just go like we just call this guy, right? So we go ret is equal to init with the things that we want. Okay. Scratch Alec. It was scratch first. Okay. Wait, that's actually kind of easy. And then I guess this stuff can all kind of be extracted now. Anything in here? Well, we'll see. For now, we might just be able to compile this twice. We'll see. Wait, what is this pissed about then? Enum literal is not a function. Oh, fine. Okay, so I think that if we just say, I would like to compile my library now with this file, maybe, right? I'm just like, yo, could we please do swim rendering zig as a library? Oops, this is the wrong wrong one. So this is source swim rendering dot zig. Compile this thing as our shared object. This guy needs now to, you know, root module add import of this guy. I'm sure that there might be more problems here, but we'll kind of GL system bindings. Ooh, wait. This might be wrong. This might be wrong. I'm not 100% sure. Let me double check. Make WM. I think server bindings is the one we want. No, make WM. That's fine. Fuck. I think we just need to move this somewhere else. Hold on. This goes in the window manager section now. We're doing some hacks. We're doing some hacks. It's fine. It's fine. GL bindings is what we want. Self B install artifact DL test, and then we'll put a fix me, move out, and support D check. Okay. Okay, cool. This thing compiles now. This thing compiles, and if we look at zig out lib this thing, we should have a function in here called init gl state, right? So that's good. That's good. And now I'm curious if we can, in our renderer, I want to see if we can do something like this. I would like to call this by doing a DL open, right? So it's dyn renderer is going to be stood dyn lib open zig out lib whatever lib deal test fix me up dot slash lib, but this is fine for now. Maybe this lives here, and we have dyn renderer here is a stood dyn lib like this. We'll figure this out eventually, but for now, this seems reasonable. And now here we do this as dyn. We might want to do some lookups here. So init gl state dyn or something is a pointer to a function of params that takes an init gl state params with call conv c that returns an any opaque. I guess for now it returns a gl render state. That's fine by me. And this guy's like init gl state is dyn renderer lookup of this type. So init gl state function is this. Okay, so then we look up this init gl state function with init gl state. Okay. So he doesn't like this for some reason, probably because this thing needs to be tried. No field. Dyn. Okay, this is mad because this thing needs to be variable now. Okay. What am I missing now? This thing needs to dereference this thing, and then it's probably more like this. Okay. Does that compile? No. Because expected union type? Oh, is this backwards? Oh, this thing isn't failable. Oh, my bad. I just assumed. Seems like the type of shit that's failable. Okay. So now this guy, we want to call now self init this thing. With alloc is alloc, scratch is scratch, right? Just get crazy with it. Preferred GPU is preferred GPU, right? Resolution is self composer state resolution. And then here he's like, I wanted this to be non-const. But I think that's fine. We can just change this to say const. I don't see any reason why that's a problem. Okay, so now this guy is a double pointer, or he is a pointer. So this ampersand goes away. Okay, let's see if this still, like, works at all. Right? I would be surprised. So we are segfaulting. Why? So it could be that our two guys both have to be linked with libc for us to like kind of take the right path on both, right? If we're using structures, these structures need to have like the same options enabled if they're used on either side of the API, right? So if we're doing link libc on one end, that's going to change a bunch of shit. So we need to do it on both. That's going to be my assumption here. And also, if we're using LLVM on one side, we probably need to use it on both. That would be my guess as well, actually, now that I think about it. Otherwise, like, it's going to cause all sorts of problems, right? Like, he's just going to have different representations of the same thing, right? That would be my guess. So let's try this for a second. Let's just see what happens there. This seems sketchy as fuck now that I'm starting to think about it, but okay. Now we're segfaulting. Where are we segfaulting? In initialize GL params. Surprise, surprise. Oh, because all of these libraries that we're linking also need to be linked into our library, right? Because he's trying to call into some like OpenGL functions that are no longer available. So we'll just do this for a second. We'll see what happens. Unlucky. So I want to know what's happening here. Ziggo, so if we look at like, what does our shared library link against? He does link against libgl. He knows that he's there. So that's interesting. It feels like this should work to me. Right? Because like this segfault is pretty clearly like he's trying to call, he's trying to call this function and like he doesn't know where it is. But I would think that if we're calling DL open, like I don't understand because it should be mapped in, I would think. We can do this though. PS aux grep swim. And we can take a look at proc swim maps and grep for GL. So libgl is in the process space, right? So that's good, but maybe when you dynamically link a library, he doesn't automatically get all of the like all of the mappings that the rest of the executable knows about. You know what I mean? Like we might have to say, hey, resolve all these symbols, sir. It feels something like that. Oh, fuck me. Is this like some bullshit where, we are using... We have to call initgl maybe. So we have these like OpenGL bindings where we have these like public variables sitting in our process like somewhere, right? And we dynamically load these things. And maybe it's like there are all of our global variables are like in the shared object now, right? So this like initialization of OpenGL stuff that we were doing before actually needs to be done again in the shared object. And it was kind of like a bug that it was where it was. So we kind of want to do like stud render initgl with systemgl get proc address. This is my current guess. Let's see if that changes anything. Oh, let's fucking go, dude! Let's go! Okay, this is very cool. This is very cool. So now all we have to do is like move the render part into here as well. Right? So pub export function render. And he's going to take in GL state, GL render state, and he's going to return maybe, why are we doing this again? So that we can hot reload. So we can hot reload the window manager, just the rendering portion of the window manager, right? So we need to keep all of the like Wayland connection state exactly how it was, and hopefully like the compositor state can kind of stay as it is as well. And then all we are doing is hot reloading like style Is that something we actually want? It's something I want. I want to try it. If it's easy, it's easy. If it's simple and it works, you know. Render compositor state. I just want to see. Maybe it's not worth it, right? But maybe it is. Okay, so here we take in our GL state, the compositor state, and kind of move as much as we can in here. So I think we just kind of take all this. We do need a way to get this render buffer back out as well. But that's okay. So I think that this guy has like an out parameter. And he returns a Boolean for if he succeeded or not, or something. And then this render function just is like this. Render compositor state with self GL state. Compositor state. And red. Kind of like this. Catch return false. Or error failed to render. Render compositor state error so that we can have, you know, a little nice you know, thing like this. Okay, we're getting somewhere. We're getting somewhere. Try if, you know, if render with error with GL state, compositor state out, or else return or catch return false, return true. This is kind of the C API version of this thing. And I guess we could actually make this return the render buffer. And then we can say out is this. Okay. There we go. Nice. Nice. Okay. So now this is looking pretty good. We just put an ampersand here. And this is actually going to be like this, and we can initialize them to null. Fuck it, why not? If this fails, this is when we return error, and then we can return red. Perfect. And then all of this stuff just moves in there. We just cut and paste this out here. Okay. We're missing the delta here. I guess this is computed externally. Fuck it. Fuck it. This is computed externally. That's just a little easier for now. I don't even know if this delta is used anywhere, but fuck it. I see. We've got some problems. We're kind of like returning the wrong thing. That's what I've decided here. We need, what the renderer was before was more than just the GL state. So I think that we want like renderer, you know, DL renderer or something. That's kind of like whatever this was before. And he can like define his render function, etc., right? He can just kind of do whatever the fuck he was doing before. So here's his render function. And this is on like the right side of the API boundary now. So we just kind of like move all of this stuff that he had before into him. Okay. But not with compositor state. Compositor state still lives outside. This still lives over here. But everything else lives in the new DL thing. This guy now actually returns he doesn't return GL render state, he returns DL renderer. And everything that this guy takes in is like, I think here we have DL renderer like this. And we call like this. DL renderer is equal to this. Okay. And then we can just call this function on him. Perfect. With the compositor state and the output. Except it's going like this. Okay. This is looking pretty close. Pretty close to being correct. Yeah. This is looking kind of close. Now, there's some clear problems, but let's just, you know, see what they're complaining about. This guy's no function domain in it. So true right now. So this is going to look a lot like this. Okay. Boom, boom, boom. This GL state goes in here. DL renderer, great. Okay. So now this can just be GL render state init. I think that this init function actually is out here. That's fine. This will work. Alec is these guys. All of these guys from here go in here now, and they just kind of get passed along. Okay, I think we're getting close. Kind of like this. Okay. Is this right? Resolution? Oopsies. Okay. So this guy also needs last render time. So instant now. Like this. We got render in progress is false. Background animation state is 1.0. Okay. I feel like render in progress can't live over here because this is memory that is going to be accessed by the render backend. So this render in progress part has to live outside. But everything else should be okay. So now when we call render here, what is he returning? He's returning like a render buffer. He's going to say, if self render in progress, return null. There's no work to do. But now, other than that, we're good to go. So we're going to call like render compositor state with our self DL renderer and self compositor state. And I think that's kind of it. I guess this is going to, and output, right? So we forgot this part where we say like, ret is a render buffer, is null. We return ret if this works. And then if this fails, return Error, render failed. Okay. That feels like we're close. Definitely feels close. Okay. We've got some shit backwards here. Let's just fix that real quick. Expected error union type, so this guy has to return error because he can fail. I forgot. This guy needs to write try here. What's next? Expected 0 arguments, found 1. Hello. Oh, this guy does need to take the compositor state now. Because he doesn't own it anymore. It lives on the other side of the API boundary. Expected type this, found that. So this is not a pointer anymore. So true. Because he lives over here now. Expected type this, found that. So this guy returns a DL renderer now. Okay, unused function parameter compositor state. And okay. We can fix that. So self.compositor state is just compositor state now. Okay. Expected this type, found that type. This thing needs an ampersand now. And it looks like we're building. Which means that we might run. Oh no. Wayland, whoa. Okay. So somehow this is ending up. Oh, requesting new frames from the compositor is a bug. That's okay. Oh, okay. Hold on. So he's trying to call into stuff that he shouldn't be anymore. Where? There's also a lot of other problems here. Okay, compositor state here. It takes in compositor state. I guess what we should be doing here is taking in const compositor state so that we don't accidentally try to call functions on it that could mutate stuff. We're not allowed to change shit. We're like purely an observer on this thing now. I think is the fair play here. Okay. Oh, but we can't iterate the storage shit right now because this guy requires self like this. But I think we can just kind of cheat it a little bit. If we do like this, are we back? Throw a little consts in a couple spots. Okay. Delete a couple selves. Delete a couple selves. Which means that render cursor doesn't take self anymore. Okay. No field named DL renderer. Okay. So here we need to do init DL renderer now. And I guess we on init GL here, we assign that thing. We like DL renderer is init GL state done or whatever. We lost that. Where the fuck did that go? Oh, whatever. We'll figure it out. Okay. So what does this guy want? These things. These things. So I guess these just get passed in. Compositor state, compositor res, and then this is preferred GPU. I think this stuff used to be passed in here, and we just kind of lost this function because stuff is getting moved around. But that's okay. That's okay. So who calls this? This guy with, yep. Okay. He's just passing against Alec is a stud Alex phallic. We've got Scratch is a stud Alec linear allocator, and then we got preferred GPU as a string. Okay. How close are we? Okay. Somebody's still mad about this like WLIO thing. But I don't really know why. Let's see if we can kind of trace this thing down. Zig build f reference trace. Somebody is referencing that thing that shouldn't be anymore. This is coming from source info Wayland connection. Oh, sure. Okay, we can just link that module. That's not the end of the world. We'll make it work. It's fine by me. Oh, so we just kind of need to do the same thing where all of our imports also get thrown in here. I'm not above it. We will import all the same imports. I don't give a fuck. Dude, you can't stop me. This function now needs to return a DL renderer. Init, DL, whatever, it's fine. We'll fix the names later. Okay, what's next? No function, no field name GL state. Okay, right. Because now there are other people who are trying to access our OpenGL state directly, but it's on the other side of the API boundary now, which is a bit of a pain in the ass. So these, what are they trying to get out of this thing? He's trying to get the device handle that we're supposed to use, if I remember correctly. So he just doesn't need to come from here. This thing can come, is a U64 that comes from somewhere else. Here's what we'll do. We will expose a function on this thing to get the device handle that we're rendering with. No, because we know this before we do anything. Like, before initializing OpenGL, we already know this information. Which GPU do we want to use? So can we figure that out? Can we just pass that along? Like, preferred GPU handle is a U64. I'm pretty sure that's all this is for. So somebody is going to ask for that thing. Preferred GPU handle, preferred GPU handle. This is just kind of like initialized one time on init, probably. So I guess this kind of goes here. I don't know, man. I don't know. So when we kind of construct everything, we get kind of like render init info. This thing just needs to return a device handle, right? Preferred GPU dev t is gonna come from format info preferred GPU. Boom. For now. For now. This has to get passed along just to one more spot. Like this. He gets passed along. And then for now, we do just a crashy in this path that we're not taking right now. Okay, now the format table. So we need to get a list of formats from the other side. So what we can do is this format table construction. I think that we just move this into the renderer. Because he's who owns the OpenGL stuff. It's the only thing that makes sense. Sure. So can we do something that's like make format table? I'm not the biggest fan of this, by the way. Format table is owned by Wayland, kinda. Like the format of the format table is like a Wayland concept. So I'm not like the biggest fan of how I'm doing this right now, but we have to make some sacrifices as we try to figure this shit out. Okay. I guess this is actually more like a exported function. Out format table bool like this. I don't know, man. I don't know. So here we just do like out is equal to a format table init. So he has some parameters that he wants. I don't know, man. With the GL state, EGL context or something. And if something goes wrong, we return false, and this guy probably wants a pointer or something. Okay, return true. Okay. And then our renderer exposes this thing. Pub function make format table. Returns the format table. And he does something here. So he calls like self render make format table dynamic with the stuff that he cares about. Okay. Yep. So he has the return here. Format table is undefined. He returns the format table, but maybe this thing fails. So if that happens, he freaks out. Ew. Ew. This is not nice, dude. Not nice. Okay. Okay. Few things have moved around, so we have to fix that. This guy doesn't have make format table dyn, so we have to make that. Which is a make format table function that lives on the other side of the API boundary. So where the fuck we define this thing? We need like make format table function takes this stuff and returns a bool. Okay. So now this guy needs to be like make format table dyn is equal to look up make format table. Okay. Are we fucking getting there? Okay. Expected this type, found that type. So we need make format table dyn function here. Oh my god, I'm gonna lose my fucking mind, dude. Expected type this, found that. We'll just dereference. Dereference. Okay, this guy wants from rendering here now because the format table has moved, even though it shouldn't have. This guy's like, yo, let me throw the preferred GPU handle at you instead of the GBM context. This guy is going to take in preferred GPU handle as a U64. We get it one time on init, which means that here he says preferred GPU handle here is a preferred GPU handle here. And then somewhere he's going to be like, yo, we need this guy like this. And this is self-preferred GPU handle. Holy. Okay. Do we finally build? We do. And do we still run is the big question. We do. Let's fucking go. Okay. So the moment of truth here, I guess, is we need to do some sort of like hot reloading shit, right? So we need to like tear this whole thing down and reinitialize it on some like button press or something, right? So what we want to go is go to rendering and do, I think we need to export like a close, like tear down function, right? So here he goes like DL renderer dnit, right? This might not exist yet, but let's see. Let's see. So this guy is like takes all of his, I guess, his like self GL render state, dnit or something. Which means that this guy needs a dnit. And the big things here are we have to tear down our OpenGL context. I think that's kind of it. Okay. Okay, so now we can make like a reload function on this renderer API, right? And what is he going to do? He's going to like reassign the renderer, right? He's going to like kind of like reopen the dynamic lib. He's also going to like maybe he needs to write down the teardown function as well. Dnit state dyn or something. So this is kind of like this. So he's going to, what is the function called? Like dinit DL renderer, yeah. Okay, cool. Dinit state, okay. A lot of these, you know, there's a lot of like shit show stuff that's happening here. But we'll get there. Okay, before we do this, though, we kind of have to close the old one. So we want to do, like, tear down the old version, right? Like this. Then close the old version. Right? Cool. Then reopen it with the new version and extract the new functions. And then call reinitialize on this thing. Yes. Okay. That feels okay. I mean, there's a lot of stuff about this that is not okay. Like, just kind of like all of the APIs are shit. Nothing feels really right, but I think that this will work, which is the important part. Which is the important part. And so now we just kind of have to force a reload. So where is that going to take place? For now, can we just do it on mouse click? I think that's easiest. I guess we can actually do it on like spacebar or something. Because we have access to the renderer from our Wayland shit. So we should just be able to be like, we'll just do it here. On mouse down. On mouse down. We will do self renderer reload. Which is going to take a bunch of stuff. Which is fine. We'll write this stuff down here for now and figure it out later. Figure it out later. What the fuck? Probably shouldn't belong here. Actually, here, no. I don't want to write it down here. I want to write it down, just in this guy. This makes more sense. In the renderer, he can hold on to whatever he wants. Okay. And then he can pass that along when I reload. Easy. Easy. Okay. So now when this guy's initialized, we have some fucking problems. So we need to write down these things that we're going to want later. I think preferred GPU is actually can't be done right now, but the rest can. We're taking some creative liberties here. Pass an allocator here and a scratch allocator. And then after we have access to preferred GPU, we assign it like this. Okay. A lot of hacks. A lot of hacks. But maybe we're close to working. But also maybe not. What is this guy pissed about? Okay, reload here. We need to try on this guy, I guess. Okay. So if I if I press my click button here, he does try to reinitialize, but seg faults, which is not good. That is not good. Not good at all. So I expect that maybe there's some sort of like global OpenGL initialization that can't happen twice. Maybe. Or our like OpenGL teardown is wrong. Both of those things are very real possibilities. Very real possibilities. Let's just make sure that like we did call that dinit stuff if that we meant to. We are supposed. Okay, do we call this somewhere? Okay, let's go here and just kind of breakpoint on EGL deinitialization. So that does in fact get run. Okay. Maybe EGL terminate is a no-go? Maybe we're not allowed to like tear it down and bring it back up? Nope, that's not it. Okay, so it feels like, we could try to move the EGL stuff to be kind of like long-lived outside. That's not crazy. Maybe that shouldn't belong. Maybe like OpenGL stuff shouldn't be in there. But like, it also kind of feels like maybe it should be. It feels like having all the OpenGL stuff inside the shared object is like a nice, like forced constraint. You know, just shoving that all in there feels nice. It makes like a nice clean boundary for later. Oh, my phone fell to my pocket again. But the question is then, am I allowed to destroy the EGL context and bring it back up? Maybe we forgot a function. EGL cheat sheet. Nope. Let's see here. Okay, create context, destroy context. Maybe we're supposed to unset the context first. Reinitialize EGL. Maybe that's like a... Maybe this is like an ask the idiot type thing. Can I tear down and reinitialize EGL? We'll see. Yeah, this sounds familiar. We did not do this. We did destroy surface, destroy context, terminate. Okay. We do not do that, so... Make EGL, what do you say? Like, make current... That kind of lines up with what I would have guessed here. So, C, EGL, no surface. C, EGL, no surface. EGL context. Context. We can pray, hope that this will be a fix, but it is a little sketchy. Yeah. Unlucky. Unlucky. So, can we debug this at all? How do we debug this? Up, 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 up. It would be nice to have like debug symbols here, which I think we can do if we just kind of we ask, if we ask GDB to download the information from, you know, the Nix repositories. Yeah, here we go. He's like, okay, nice. Okay, so what is this? We've got MTX is a null pointer. So this mutex is a null pointer, right? So screen is a null pointer. Whoa. Okay, so in here we have list 680 or something. Like, what's going on here? Sure. So this pipe front end screen is also not quite there. Oh, did we forget to DL close? I just want to make sure. We DL closed our renderer, but that doesn't necessarily mean that we're closing the OpenGL stuff. So there could be some like leftover resources there. But let's try to figure out where this stuff comes from. Up, up, up. So F screen somewhere. This is in stmanager.c1176. Okay, let's go take a look at Mesa code and see if we can figure it out. Which version of Mesa is it? I think it's this one. stmanager.c1176. So this is coming from get current context, which might be like a thread local or something. Right? This sounds like some sort of, you know, thread local storage context. So did this guy talk about some thread local stuff? Yeah, this sounds familiar. This sounds likely. The idiot sometimes hits. Maybe. Let's see. Right, so he's saying release per thread state. Reinitialization, we do like normal shit. Let's see if that changes anything. Because it does seem suspect, you know? It just kind of does. Oh! Let's fucking go, baby! Okay, so now, when I click, something's happening, and I want to see what happens if we open a window. So let's run our demo app here. So he should be rendering in here, and then we should also be able to render our like Wayland client, right? Bad news. Oh, right. So he's never swapping buffers. I forgot. We disabled that somewhere, and we have to bring that back. But now we should be able to. We should be able to change something about how the renderer works and have it like re-trigger here, right? So if we wanted to change maybe like the color of the window borders now, could we do that? Could we do that? Rendering. So can we do something like change the colors of the window trim? Let's make it like this, and we'll type make, and then I will click here. No dice, huh? Fuck. Wow, that's so much more confusing. Wow, wait, that's really confusing. Because it looks like things are re-rendering. Can we change the background color? Like change background red. See his mom, what's going on? Wow, how confusing. Maybe it's caching. Maybe it's caching the library path? Somehow? Did you do the code that figures out when to reload? I missed it. I just did it. I just do it on click. I just do it on click. So yeah, it could be if like the DL open cache. Does it cache? What Wayland server do you use as your client? It's my Wayland server. It's all mine. But I mean, everything is running like, I mean, I guess we're technically running through Kwin. But that, like, we're running our compositor in a window and then we're using our client inside that. If that makes sense. Interesting. Could you link that compositor? It's all in my repo. It's all in here. What are we doing? We're working on our window manager, trying to get the renderer to hot reload. Okay, I want to just like quadruple check. So the fact that the rendering, like the render loop resets, we like see that happening, indicates that this reload is happening as well. The confusing part is that this seems to not create it seems to not result in any new behavior. So here we have green background, and when I click, it sure is like reinitializing OpenGL. We see all this OpenGL initialization happening. Can we look to see if I type zig build here, so I want to change this, right? I want to go in here and I want to change this to try to be red now instead of green, right? Okay, so render green in the background, please. So if I lshl zig out bin or lib, we should see libdl test modified at 1551, which is right now. And if I click here, it's like it's reinitializing, but green still. So the question is why? Can we do something like ls-l proc the process that we are running, so pgrep swim, and can we look at the file descriptors that are open? Does that no, but can we look at the maps maybe? And can we grep for DL test or whatever the fuck it's called? It's libdl test. Okay. So am I expecting this to change? Yeah, I can. Well, does DL open and DL close force a refresh? Like, that's kind of what I'm curious about now. DL close. DL open does not refresh library or something. Interesting. Interesting. You cannot rely on DL close to work as I would expect. So then how do I make it reload? Hot reload DL open. Like, am I missing something? Am I missing something? It feels like we're missing something. Right? Like, it seems like DL open is allowed to cache the symbols or something, and we need it to not fucking do that. There's maybe this RTLD local. I saw that in one of the page. Something I just saw looked like that. So can we specify some flags when we load our library Zigway? Um. Hmm. Not particularly, huh? So we maybe have to specify this manually. Okay, let's just cheat really quick. How the fuck does this work? Oh, crazy. Okay. So can we cheat? Dine renderer is equal to this. Here we go. Okay, let's just see if this changes anything. And I think we have to do this twice. Okay. Wait, he doesn't like this. Great. This doesn't even fucking resolve. Very cool. Very cool. God damn it. God damn it. Maybe it's in here. Yeah, here we go. Global. Local is 0. We just set that to 0, I guess. Something like this. Gotta run by. Yo, yo! What's up, what's up? Hey, everybody. Hey, Atom Raiders. You're kind of seeing us jump into some, like, pretty hacky shit. Some pretty hacky shit. We're trying to make a window manager. And in that window manager, we are trying to reload our renderer without restarting the app. Which is a little hacky. A little hacky, but, you know, maybe it's okay. Whoa. What is he pissed about? What is he pissed about? We're pretty used to hacky shit. Hell yeah. Hell yeah. Am I in the wrong folder? Does this thing require, like, zig out, bin, or lib? Oh, sorry, did I type? No, that's right. Zig out lib. Libdl test. 437. What do you mean file not found? Was it doing some shit where it's like home? Was that POSIX path thing that we saw in the other path here doing some cheating? Was he doing some like convert to absolute path type shit? I don't think so. I don't think so. So then what the fuck is the problem? What the fuck, man? Yeah, very strange. Okay, we'll give him absolute path. Just in case. Home, streamer, works, Wayland, client. Like, surely not, right? Okay, let's try to cheat a little bit less. So this before was calling open with this path. Let's slowly work our way back. Because clearly we're doing something wrong. Okay, so does this work? Yes. But then when I refresh it, it won't. Right, that makes sense. That makes sense. Okay, so then what is this doing differently? He is calling inner type open, which calls this and this, kind of hand wavy. Hand wavy, something like this. Dyn renderer is a stud dyn lib like this, right? With zig out libdl test also. So this should be the fucking same. Does this compile? And does it, or, is this the same? Should be. Ampersand here? Probably. Probably. Okay, so does this work? Yes. Okay, that also loads. Then if I do... maybe it was the fact that I removed the lazy? Yeah, it looks like that was it. Yeah, okay. So... the local flag is 0. Global is false by default, so I'm not actually convinced after all of that this is relevant. Maybe we can try... yeah, I'm not really convinced that this... what does 2 posix path do? I think nothing in this scenario. I think I was just confused. That is my guess right now. Okay. Okay, so it doesn't look like... so remember, we saw that local flag was 0. 0 by default, like, local by default, not global, not by default. So we're going to go back here to trying to do a hot reload, and it's not going to work, probably. I think we're back to the state we were in before. We're almost certainly... it's caching the old version of the library. That is our current guess. Right, so if we try to change, you know, something like the background color from red to, you know, green or something, and we rebuild this thing, and we try to hot reload, you know, we want to see him build, we see the library change, we reload, nothing changes. So can we ask the idiot? We can ask the idiot. Feels like an idiot question. I have deal opened a library. When I deal close and deal open it again, I do not see any of the changes applied until next run. Is this semi-expected behavior? Linker can cache and use that. Right, that's kind of what I'm more wondering about. How do I force it unload? Use RTLD local for deal open to avoid global symbol leaks, which... okay. Ensure all references are released. Call deal close for every deal open reference, which is not necessarily guaranteed to close. We saw in that other thing. Use RTLD local, which is hard to tell if we're using that correctly in this like Zig world, but I think we are. until we turn that global flag on. Load the library under a unique file name. That's so funny. That's so funny. Uh, okay. Okay. Yeah, let's do what he suggested. So can we go back to calling this open thing correctly? Kind of fuck all this stuff, right? So when we call reload, mylib final version 2 v2 final. Yeah. Okay. So we want to do like a copy, I guess. Hard link, soft link. Symlink. Okay, we'll just do this. So open count. We symlink this to new path is checkpoint is self scratch checkpoint. Then later we say restore this checkpoint on the allocator, free all our memory. New path is a std format alloc print of, libdl test number with open count. Okay, and then we try to symlink this to the new path like this, and we want to allow overwrite. I guess we just need to remove that file first. Unlink, remove, delete file of new path. If we can't delete it, we're good to go. Then we open a new path. This is such a hack. Okay, what's going on here? We forgot to try here. Then this guy, we need allocator. So true. So true. This is like Ajax caching. Yeah. All right. Are we there yet? New path. Okay, we'll try this. Boom. Try with the new path. And maybe we're chilling. Okay, so it's blue. Blue to white. Okay, perfect. And then can we please, God, change this to go from blue to whatever. Purple or whatever? Maybe cyan? I can't remember. He crashed, which is different. Failed to pull file not found. Wait, I fucked this up? How? Oh, the symlink probably failed? Probably. Did I do the symlink the wrong way? libdl test 0.so. Yeah, I fucked up because he needs to link. It's probably like a relative path, right? It's probably like. Hold on. Yeah. It's like this. We need to symlink adjacent. But then like the loader still might not respect. He might be smart enough to resolve symlinks, in which case we might have to hard link. which is kind of funny. Okay, blue. And then let's go red now. Just copy it, yeah. We might have to. Yeah, he's too smart. Too smart. This is so stupid. This is so fucking stupid. This is so dumb, man. Alright, let's try that. Okay, blue. No, really? No. Even with a copy? That means that we must be misunderstanding something, right? It has to be that we've fucked something else up. Cat proc p grep swim maps grep libdl. Oh, not libdl. DL test 5? Okay. Wait, the plot thickens. The plot thickens. We are changing libraries. I'm sorry. Stood deb. Okay, is it something else? Like, stood debug print. Hi, mom, I'm on TV. Like, does this show up? No. Right? So it's like, obviously this is not getting called. Are we just fucking... We're fucking calling the old... Oh my god, I didn't split the functions. We're not dynamically loading the one function that matters. That's so funny. We fucked up the one function. Render dyn. Render dyn function. Oh my god. Oh my god. We should have fucking moved stuff into their own modules. We deserve this. Oh my god. Oh boy, oh boy, oh boy, oh boy. Alright. Alright. We're gonna pretend that we didn't just spend however the fucking long we spent on that. Okay? Everyone pretend you didn't see it. Okay. He's blue. We come here. We change that color. We remove the printf. Make him red. Build. Reload. Come on. Wait. Oh, wait, we actually have to call the function? You have to call the function if you want to call it. Did you know that? I always forget that. I forget that like every time, actually, if I'm gonna be honest. Like most times I forget to call the function I want to call. But sometimes we don't forget. Okay, so now he's actually crashing because... Whoa. Wow, that's so much more confusing. So now we can't render at all because we're attempting to use a null value on preferred GPU. Oh, that's fine. But here he's trying to call a GBM function. And maybe that didn't load. So this is like with no hot reloading now, just trying to go over the API boundary is failing now because we weren't actually fucking calling the right function before, which is very funny. Interesting. Oh. Hmm. Wait, I'm confused. It looks like we're getting like an invalid buffer. Right here, we're calling into buff 0, which seems wrong. Right, so we're in here, and somehow backend rendering buff has been set. Is this our second render call or our first? It feels like our first. Which makes it feel like this GL render state has not been initialized correctly. That's just kind of like my gut feeling here. But we could just double check this as well. We could be like std debug print render here. And if this is our second or first render, that'll change kinda. Yeah, so it looks like on our first render call, he is seeing a previous backend rendering buff, which should not have happened. Right? So something is going wrong here where maybe the DL renderer state is invalid for some reason. So when we call render compositor state, we get these three guys. Our render dime function has those three guys. Are we forgetting to call this? No, initGL happens here. And this guy, we do dereference him, so he should also be okay. Interesting. This is a, yep, to a pointer. Let's just quickly take a look to see what's in him. Okay. So it's not just like fully zeroed out or anything. And here he thinks backend rendering buff is wrong, right? So or null. So he thinks that it's null when he calls render from this side. Then we get into the render function on the other side. And here, if we just run the same thing on self, does it look different when it gets over the boundary? Because that would be interesting, right? Okay, so specifically we're looking at yeah, we're seeing some definite differences here, right? Like this, right? So it feels like the padding and stuff on this structure is different than we expect. Did I know, but like it's all on one side, right? It should be all initialization happen on one side. I guess if the size of this is changing, I guess that's possible. If like on one side we are expecting this thing to be like 20 bytes, and on the other side it's 25 bytes, then like we might be like we might be clobbering ourselves somehow. Yeah, it could be something like that. So which would indicate like compile parameters aren't quite right. So let's just try real quick. What does it think the size is over here? Uh, like this maybe. And can we print this on the other side as well before we render? Okay, so on one side, these are the exact same, right? So that's a somewhat good sign. The less good sign, though, is that he seems busted. I mean, is it possible that we didn't initialize this thing? Can we double check that this is called? I mean, this has to have been called because we're seeing all that GL initialization stuff. But okay, so this guy on an allocator, he says, yo, let me make some long-lived thing, a DL renderer, a long-lived DL renderer. After this, can we print out what we think this is supposed to say? So after initialize, we see this bad boy. I'm sorry, what? Oh, sorry, that's a normal bug. So after init, we have, device is a GBM device at 2E5F9610, right? Then, later, when we call render, this is wrong, right? So there's got to be some form of memory corruption. It's the only thing that makes sense. If somehow the allocator state is wrong somehow, like we're passing this allocator over the boundary and he's like, yeah, I'm fucked. Like that's the unless like we're like resetting this allocator sometimes, which I don't think we should be. That would be insane of us to do. Let's take a look. So this guy initGL is getting our root allocator, yeah, and it's not like we ever are doing anything stupid on this thing. We're expecting this thing to be long-lived, so that doesn't really make any sense. Interesting. Interesting. Can we print... I'm so confused. Can we print after init on both sides, just in case? Like, I just want to understand. After init, other side. Not like that it should matter, really. But I am curious. I am just a little bit curious. $4086. So they are in agreement at this point in time. So that's kind of interesting. They agree on where this thing lives. Is it possible that like who's calling reload on this guy? Or not reload, render. Is it possible that like this guy's passing something that he shouldn't? Does this guy have to be mutable for this thing to work properly? That doesn't sound right, but maybe. Does not sound right to me. No, okay. Hum. Okay, hold on. Let's GDB this thing. we're gonna crash. We're gonna be in render. And like is this right? This looks relatively correct. Like the top level renderer state. It really feels like just this allocation is like not getting tracked correctly. You know, it just really feels like I don't know, like before in it, we allocated this much memory. And then after, is it like not getting tracked correctly because of like some bullshit? Total shot in the dark. Are the allocators ultimately backed by a GPA with thread local storage, which gets confused? They are not thread safe, but my allocators are, they are, sorry, my brain's melting. They are not thread safe. I will say that, but we are running in the same thread. But are they accessing global memory by mistake? They might be somewhere. And maybe like because of the way that the shared objects are loaded, like there's some sort of global variable that is different between them. That seems kind of likely, right? We have seen that global variables are isolated from each other. So it's possible that like in the arena path, what is happening here? I guess we just have to go all the way down here, right? So we have like arena bump allocator who calls in allocate. He might get into like the page allocator. But they should have like the same fucking process space. But like maybe, yeah. So like this guy, he gets into like the block allocator, who's just like another allocator. So our block allocator is what? Hold on. The general purpose allocator does make it. No, this is all. Okay, this is a block allocator, which has an array list of blocks, who is backed by some page allocator, whose page allocator is page allocator, which comes from tiny page allocator. Our tiny page allocator does talk to the actual page allocator. So there's like maybe something there. We're like stood heap page allocator on Linux. I don't see any global variables on this path. Jesus Christ. Okay, but like just the fact that I have to worry about that is like fucking scary, right? Right? So like maybe this is just a bad idea. Is that the answer? This is just like a bad idea to pass. Like it feels like passing these zig structures over the line is scary. So hold on. I mean it could be that like we might be drawing bad conclusions here. There is a chance that of that. I would like to see what is the pointer address that we got out of of this thing. So when we call init DL renderer, can we get the pointer that this thing has? Right? What is this? What address? Addy is this guy, which I think you put log like this. And what I want to know is if this was tracked correctly by our allocator. So what I probably want to look at is like stood. I guess I want to see like for each block that we've allocated. Let's just see if one of these is correct. Block like this. Right? Just something like that. And then does this thing have like its size? Oopsies. Fuck. Block. Can we do like pointer block len? So we were at FFF75DE330. 75DE000? How much is... Yeah, I mean, that should be in here, right? So it looks like he's tracked correctly to some extent. But then why is someone overwriting him? And why is it only when we use render dynamic? Right, if we go back to not using the dynamic version of this thing, we use the one that we compiled in to our binary. That was working, right? Which is so much more confusing. Right? So it's like something related to passing. That means that this render state is valid by some metric of valid, right? It's only... Let's just throw like 3 renders in a row at this thing. I just want to see, you know, I don't really have a good answer for what I'm looking for. It's just so strange. Is this API, did I get this function signature wrong? Oh, call conf C, call conf C, call conf C. We had the wrong calling convention. No. Oh, still broken. Well, did we get the return type wrong? Is that what's happening? So it's like, it's... Render dyn is a render dyn function, which is this type. Is this exactly the same type here? DL renderer, compositor state, out, bool, oh, call conf C here as well. Maybe. Oh my fucking god, dude. We just forgot call conf C. Okay, wait. So now if we go back and we try to actually change some shit here, are we back to working? Is this... Did we finally fucking get it? Let's go! Let's fucking go! Holy shit, we finally got there. Okay, let's fucking run our demo app. Right? We got our little pink window border in there. We go in, we change our fucking code. We change it, and we say, let's make the fucking window borders yellow again. We'll make the fucking title bar yellow, or, yeah, yellow, but the fucking other border's pink. Boom, baby! Let's fucking go! Let's go! And then we can fucking, I don't know, like, only render one, right? So if true return. So before we do this, we open another window. So we have, oopsies. I did just rebuild by mistake. So like run the client, our other thing. Boom. Oops. Okay, reload. This shit's here. Boom, boom, boom. And then we do some shit. We go, let's only render one window. Boom. And then we hit go. Oh my god, one window's missing. Crazy shit. Crazy. Does it work without copying the lib now? Probably, right? Surely. Let's try it. Well, yeah. Because, yeah, that was a hack that seemed wrong. Okay. Quit. Alright. We run this shit. Green. Right? We change it to background color. Force it red. Rebuild. Click. Yeah. Nice, dude. Nice! Let's go! Okay. So, what did we learn? This is hard. This is hard. This is sketchy. We made a ton of hacks. But in reality, like, it is just export the function and call it. It seems like it is semi-valid to pass zig structures over the line, but you have to be very, very confident that you are using the exact same compiler flags for both versions. Global variables are scary, right? We did see some stuff about that, like, for example, EGL. We saw, like, global variables for EGL were not resolved. If we had to, like, move some initialization there. We saw tearing down and restarting an EGL context is kind of hard. So maybe, like, putting all of the OpenGL stuff in here is, like, not the play. Yeah, there's a lot of, like, sketchiness in here. Right? So I'm not sure I'm a big fan of this. Like, a better answer to this involves, like, a lot more safety. I just don't know what that looks like. So I'll think about it. We probably just won't do this. Right? We probably just won't do this. I think a better answer to this same problem, right? What was the problem I was trying to originally solve? What if I want to change the renderer and I want to see iterations of that thing quickly? And I was struggling because I was like, I don't want to have to, like, reopen all these programs again in this Wayland environment. The right answer is just to automatically open them, right? That's a way easier fix to this problem. You know, this whole thing could be avoided with this, right? You write run, whale, like swim, run this in the background. Wayland, like, Wayland display equals 1. Wayland client, right? This gives me everything that I wanted, but is just, like, not a giant fucking hack, right? This is better. And then if we really wanted to get crazy, right? We want to test, like, specific, you know, window locations and orders and stuff, what we should do is like, you could instead do like initial app config or something, right? You could pass in some sort of like spec for how you want windows to be laid out, and or you could like mock some windows even. All of those options I think are better than what we just did. I think what we just did is fucked, right? Because it's not like our window manager startup time is slow. If our window manager startup time was really slow, this would be a problem. But in reality, we can just rip this shit so fast that it doesn't matter, right? Like, and in fact, because of the fact that our hot reloaded shared objects had to be compiled with LLVM, the hot reload path is actually going to be slower than just fully restarting. So what we have is a slower, shittier, more dangerous, bad API. That's what we made today. So I guess we just don't do this ever. But it works. And we'll also throw the caveat in there that maybe I did something wrong, right? So my read on this right now is that I would not fucking do this. But maybe somebody will watch this and they'll say, you're a fucking idiot, do it this way, and maybe I'll look at it again. But for now, we assume that we will never do this ever again. And fuck that shit. Thanks for watching, guys. If you like what you saw, we stream most days 12:30 to 4 o'clock Pacific time. It is 4:40 now. We're a little late because this was hard. But we're working on this window manager. Swing back by tomorrow, maybe the next day. And we'll be working on it again. There's a YouTube link in the Twitch description where you can catch most feature development. Some like refactoring and unit testing and like reading and that stuff does not make it up on the YouTube all the time. There's kind of like extra. The Twitch streams are longer than what goes up on YouTube. The other half of the Twitch streams go up on Patreon or YouTube members, or they get archived on Twitch. And if you subscribe/pay in the appropriate place, you get access to that stuff, and you get access to the knowledge that you're helping the stream stay alive. Because if I run out of money, I have to get a job, and then the stream will stop happening. So that's all the begging I'm gonna do. Thanks for watching, guys. YouTube, peace out, and Twitch, let's find someone to raid.